So on this question, we want to find which sets of numbers would you find this number 18.6591 with the 91 repeating. So we have this list of different sets. We want to make sure that we know what are these sets. We've got the natural numbers being our counting numbers, 1, 2, 3, 4, 5, and so on. I think it's clear that this number is not among those nice counting numbers. So it's not a natural number. Whole numbers are the counting numbers including 0. And you can see that this is not a whole number. The integers are the counting numbers 0 and the opposites of the counting numbers. So this decimal number is also not an integer. So then that brings us to irrational and rational. These are two sets that are opposite of each other. There's no commonality between these two sets. So if something is rational, it's not irrational. If something is irrational, it's not rational. So once we know the definition of rational, we know that everything else will be irrational. Every other real number will be irrational. So rational numbers, these are numbers that can be written as fraction. The official definition is any p over q, where p and q are integers. And in addition, q cannot equal 0 because dividing by 0 is undefined. But there are numbers that are not written in fraction form that you can write in fraction form. And that's what we see here in this repeated decimal. If you have a terminating decimal or a repeating decimal, these are numbers that can be written in fraction form. I'm going to take a simpler example to show you. So if you have a decimal like 0.25, this is a terminating decimal. And when you have a terminating decimal, your final decimal place there is going to have some place value. In this case, the 2 is in the tenths place and the 5 is in the hundredths place. So because that 5 is in the hundredths place, we can write this number as 25 over 100. So that decimal can be written in a fraction form, and that means that it would be a rational number. When you have a repeating decimal, because it has a pattern in it, that can also be written as a fraction.
I want to show how a repeating decimal can be written as a rational number. So for example, we're going to write 0.3 repeating as a decimal number, as a rational number. I'm going to let x be equal to 0.3 repeating, and hopefully I can solve for x, and that will be in the rational form instead of the repeating decimal form. So 0.3 repeating is 0.33 repeating, and I can rewrite that 0.33 repeating as 0.3 plus 0.03 repeating. And from here, I'm going to do something that you might not think of. I'm going to multiply by 10 on both sides, and this moves the decimal point one place to the right. I'm going to multiply the left-hand side of the equation by 10, and multiply the right-hand side by 10. And on the right-hand side, I'll use the distributive property. This gives 10 times 0.3, that's 3. 10 times 0.03 repeating would be 0.3 repeating. And if you'll recall, in the beginning I said that x was 0.3 repeating. So I'm going to change that 0.3 repeating to x. That's 3 plus x. And now I have an equation without that repeating portion of the decimal. So I'm going to solve for x. We'll subtract x on both sides. That gives 9x equals 3. We're going to divide both sides by 9. That's x equals 3/9, which reduces to 1/3. So we can see that the repeating decimal, 0.3 repeating, is the same thing as this rational number 1/3.
So for this example, it is a rational number. It is not an irrational number because of that. And it is also a real number. Real numbers encompasses all of the fractions, decimals, negatives, positives, everything except for what we talked about last time, the imaginary numbers, which we haven't covered in this class. So for this example, real and rational. Okay, so then we have another one, square root of 79. Okay, square root of 79, we just went through the natural numbers. That doesn't fit. Let me pause here for a second because I'm jumping too fast. Before you decide that it's not a natural number and not all of these other kinds of numbers, you should try to simplify it. You've got square root of 79, and 79 is not one of our perfect squares. Perfect squares are 1 squared, which is 1, 2 squared, which is 4, 3 squared, 9, 16, 25, 36, 49, 64, 81. These are perfect squares. These are radicals that, if they are radicals, so if you have square root of 81, that's the same thing as 9. So there will be some radicals that you can simplify, and those radicals would be natural numbers, whole numbers, integers, and so forth. This particular example, 79, is not a perfect square, so it's not one of those. So we can eliminate it from the natural numbers, the whole numbers, and the integers. In addition, we can eliminate it from our rational numbers. We can write this as a fraction. Square root of 79 is square root of 79 over 1. But if you'll remember that little extra piece that I put in the definition, the P and the Q, the numerator and the denominator, need to be integers. And we already said that square root of 79 is not an integer. So this can't be written as a fraction, so it's not irrational. It's not rational. The opposite of that is irrational. So this is irrational, and it's also a real number. So in this example, we have a formula, A equals 1/2 h times A plus B, and we want to solve for A. So let's highlight the variable we're trying to solve for, this lowercase a. And as I take a look at it, it's inside parentheses, and there's multiplication onto those parentheses. So before we can isolate that A, I need to remove the parentheses. And there are two ways you can remove the parentheses. You can remove it with the distributive property, or you could divide both sides by what is in the parentheses. So let me show you both ways. So if you want to remove the parentheses with the distributive property, you would distribute 1/2 h times each term. And that would give you A equals 1/2 HA plus 1/2 HB. And now the parentheses are gone, you can start to isolate that variable A. So we're going to need to, in order to isolate, remove this term as well as the factor that's attached to the A. And we're going to follow reverse order of operations. So we're going to remove terms that are added and subtracted first before we remove the multiplication and division. So I'm going to subtract the 1/2 HB on both sides. That's A minus 1/2 HB equals 1/2 HA. And, excuse me? Oh, no. So then I want to start removing this 1/2 H. These are multiplied, so I'm not going to use adding or subtracting to remove them. I'm going to do the opposite. So with the 1/2, you can multiply by the reciprocal. I'm multiplying by 2 on both sides. And that leaves me with HA on the right. I can simplify distributing that 2 on the left. That's 2A minus HB when I distribute. And then I can isolate the A by dividing by H on both sides. So we have A equals 2 capital A minus HB over H. That's one way. If we made a different choice at the beginning, it would look a little bit different, but we'd still have the same answer. So we have A equals 1/2 H, A plus B. So this time, let's remove the parentheses by getting rid of the 1/2 H first. So here I would multiply by 2 on both sides. That cancels out that 1/2. So we have 2A equals H times A plus B. Then I'll divide both sides by H. I have 2A over H equals A plus B. And we'll isolate the A by subtracting B on both sides. So we have A equals 2A over H minus B. So 2 different ways we can solve that formula for A. Thank you for checking out my videos. Have a great day.